Welcome to the another session in Frontiers in Safety. The thermal management system for optimizing the performance of prismatic cell, lithium and battery with liquid cooling. So the first objective is the preparation of geometry for prismatic cell, lithium and battery separated by the cooling channels on the both side. Next is generation of mesh, name selection on computational domain and applying the boundary conditions and visualizing the result. So welcome you all. Today we'll see the battery thermal management system with liquid cooling. So we'll do the CFD simulation for the same. For this, we are following one of the research paper, which is been available here. So we'll try to follow some of the dimensions for this paper, and accordingly we'll try to generate results which are similar to here. This is a pressure distribution. So we'll try to have some temperature distribution in the system. So let's open the workbench. So fluid flow fluent. So first of all, we'll try to prepare the geometry with the help of new design modeler. So first set the units. So let's say to mm here. So this is your plane. So we'll try to have a system which is say in XY direction, and accordingly we'll prepare. So primitive, I will say a box. So here I will put the X component as 118, then Y component I will put as 63, and Z component I will put as 13 here. So this is one of the combination which is for the cell. Now, so this is the height is around 63, so we will make it add to frozen, and let's make it generate. So this is the first thing we have done. Now adjacent to that we'll create one more box which is on other side. So create say primitive, let's say box. Instead of add material I will say add to frozen. Dimension here I will specify the X component as same 118, Y component I will specify at 63 as it is. Only this component I will make it 4. So here make it add to frozen. Now I need this on the other side, so I will shift this to the Z component which is here as now. I will put it -4, so it will be on the other side. Let's generate. So you can see here the object is generated on the other side. So just check it out. This is the first solid and this is your another solid. Now most of the work that we will do on the other side. So I will hide this body as of now so as to do the work here. So let's proceed on this. Now I will create a channels which we have specified here likewise, but only thing we are going to have more channels over here. So let's start with this. So I create one more plane here. So I take this one a plane which is from I say XY plane. Here I will put XY plane. I will shift this plane by some distance that is in Z direction. So I will put it as -2. So it will be at the center here. For this we can say geometry we have prepared. So this is how it will be at the center. Now we'll start preparing the sketch on this for this particular geometry. In addition that you can further this transform this also. Let's say this one offset I will put as the Y component here. So I will put this one as a 2. So you will see it will be generated slightly above. Now this will be your reference point, and from this we are going to generate the geometry. So first of all from this we are proceeding with the sketch. So let's click on the plane and have a sketch over here. So let's draw some lines. So from this, okay, let's have it a better visualization. So from this I will take a horizontal line. It will be corresponds to 4. I will take, so as per the dimension we are going to proceed. So I will draw one more line. So this will be a vertical line which will be of dimension, uh, it should be a 59 because you have kept 2 here and the 2 on the other side. So we'll put as 59, and then we are going to prepare one more horizontal. So this will be a horizontal distance that is equal to 10 here. So accordingly we are going to proceed for the sketch. We need to try to generate a kind of we say a channel through this, and that's why we are going to prepare this one. So let's make it a dimension here as again is equal to 10. Then one more line we need to draw, so that is same as this the first one. So let's take the dimension is equal to, okay, by default it is came on the same one. So 59 is there. So then draw horizontal line here, measure the dimension here, that is equal to 10. Draw a vertical line from this. So these are the channels we are going to prepare in order to have sorry, just wrong. I think earlier is also wrong. Just will correct the, okay. So let's take it again. From this you have vertical line here, then draw horizontal line. Take the dimension this equal to 10. Then draw again a vertical line here, make the dimension as 59 here. Then draw another line from this, a horizontal one. The dimension should be 10. So this is 10. Draw one more vertical line which is coming down up to this. Then draw one more horizontal line. Take the dimension of the line is equal to 10. So each and every parameter in between we are putting as a 10. So let's proceed this vertical. Put the dimension as 59 here, so as to, let's draw one more line, it to be horizontal. Take the dimension again is equal to 10. Draw one more line. Equal to 10. So let's take this above. Again this should be 59. Take this dimension is equal to 10 again. So we are trying to have channels over here, so that's why we are preparing the geometry sketch here. Make it 10 again. Draw a line vertical. Take the dimension is equal to again 59. One more time, draw a line which is horizontal. Take the dimension again, that is equal to 10. So draw one more line which is coming from this, coming to the bottommost point. Again draw one more line which is horizontal. Take the dimension again as equal to 10. draw one more line which is going up vertically. Take the dimension as 59 here. Then one more time draw a line which is horizontal here. Take the dimension again is equal to 10. So now let's take this below. So here it will come down, and from this it will come to the exit. Okay, so we have tried to draw the sketch. So we are trying to make this as we can say channel through which the fluid is flowing. So for this now we need to make this as a kind of circle. So I will prepare arc by tangent. So this is the first line, this is the second line, let's zoom in this part. Okay, so let's take arc by tangent here. Specify the dimensions, specify the dimensions of an arc. This one, it should be equal to 3. Okay, so I have specified the arc, so you can draw it for the others also, like here. So one more time, draw arc by tangent. So this one and this one, specify the dimensions of an arc, so that I want as 3. Similarly, draw it one more time, arc by tangent, this one and this one, specify the dimensions of an arc, that is equal to 3. So we are doing this for every section which is on this side. So this one and this one, specify the dimension of an arc, so that is equal to 3. So one more time, do the same, arc by tangent, this one and this one, specify the dimension, that is equal to 3. Similarly here, specify the dimensions, that is equal to 3. Okay, so we are trying to prepare the we can say arc here. Now further work is required on the, so this is where the arc is prepared. So this will go up, this will come down, this will again go up, and this will come down, this will go up, come down, up, come down, up, come down, up. So we need to prepare the arc on the other side also. So this is going up, this coming down, so this one and this one. So here you need, so we are preparing the arc. Meanwhile, if you want, you can trim out the unnecessary things which are not required. But it can be done later also at the end. So let's put it 3. So we are trying to generate it for each and every place which is required for us. So this is, and this one, make the dimensions that is equal to 3. Here also make the arc dimension is equal to 3. So the last one here, this side to this side here. Okay, so by default it has came. Now we'll do with one operation which is called as stream. So here, so this is not required, this is also not required, this is not required, this is not required, this is not required, this is not required. So this, the unwanted parts we are removing as of now. Okay, we have done the work as far as the bottom end concerned. Now we'll move to the top. The same way, whatever we did for the bottom, we are going to do it at the top. So again, go by, say, arc by tangent. Here, this one and this one. So you must specify the dimension. Okay, already by default it has taken, so you don't need to worry about it. So one more time. So arc by tangent, this one, specify the dimension here. This is equal to 3. So you have to do this throughout for this and this. Okay. So carefully select the one which you want. So again, arc by tangent here. This one, this one. Okay, it is by default 3. So just check this one. It might be slightly less. So you need to adjust that. So one more time, draw arc by tangent. Here, this one and this one. If you see R tangent, so by default it will be the same. Okay. So let's check it if this is correct. No, it's slightly different. So make it here. So we have done it for this side. Now we'll do it for the other side. So let's take arc by tangent. This one here. Specify the dimension. That is equal to 3 now. Here. So one more time, do it for this place. Specify the dimensions. It should be 3. Let's do it. Make it for other. So most of the places we have done it. So last is left. So let's take it 3. Then last one. This one here. You need to check the dimensions. So make it 3. Yeah, so we have done it for almost all the places at the top over here. Now let's go with the operation, that is stream. So let's stream the unnecessary things which are not required. This is not required, this is not required, this one not required, this one not required, this is not there, this is not required, this is not required. So whichever the things you don't require, just you need to remove that. Here, this one, this one. Okay, so we have done almost everything for the bottom as well as for the top. So one more time, let's have a quick visualization of how things are been done, whether they are done in the proper way or not. So one more time, to just check if there anything which is pending, so you can just check it out here. Let's just see this part if it is. Yeah, so we are done everything. Now let's okay, so we need to generate a kind of profile over here. So it depends, like if you are considering the profile which is cylindrical, if you are considering the profile which is circular, so accordingly this channels will be created. So I preferably will go for the profile which is circular first. Even you can go with some other also. So I will go with the circular profile here. Just give the dimensions for the circular profile. So here it is, I will put it 3 as a diameter. Now what I will do is I will do with the operation which is called as sweep. So where the profile will be sketch 2 and the sketch 1 will be your. So instead of add material, I will put it slice material and generate. Okay, so I think it is not, there is something issue. Just check the sketch if any pending things are left. Okay, the sketch is not like this. Yeah, sketch 2 is not the right one. So I will, okay, so you cannot do the sweep operation, so delete this. The sketch should be in the YZ plane. So that is not the right plane. So I will delete this. Yeah. So one more time. This is the plane which we have. I think this is, I will create a plane. I say it is from plane, from plane, let us say YZ. Offset Z, let us say. No. Offset Z is not. So we have generated one more plane at a distance of 2 mm and 2 mm, offset X and offset Y. So we have selected this plane from face. So now we'll try to generate on this sketch. So let's have a sketch over here. So let's create a circle here. First one, it is, yeah, it should be a dimension which corresponds to, sorry, yeah. So this should be equal to, just a minute. So we'll give the dimensions of this equal to, this should be equal to 3. So this is how is to be generated. Now we will come back to the first sketch, the one which is here. From the same sketch, we are going to do the sweep operation. Earlier it was some error in the sweep operation, so now we'll select a profile. Now select the path as a sketch 1 and make it apply and then generate. So you can see now the path has been generated here throughout. So let's have a quick visualization of it. So this is how the path has been generated from end to end. So now this will be a zone through which the fluid is likely to flow. So instead of add material, I will go with the slice material here. So you have, this is the first as a casing. This is the second one. Okay, I will make it show all bodies here. So this is the first one. This is this for cells, and after that cells you have a kind of portion where the we can say the channel is there through which the fluid is likely to flow, and this is your the fluid zone. So we'll make this as a fluid over here and generate. So in addition to that, you can change the name also, but I will do first is one operation which is called as the pattern. So over here, so select the geometry. So this is the geometry that I will select along with the this one and this one. So make it apply. I said direction I need here, so it should be separated by 13. Select the direction. So we have done the pattern at a distance of 17. So now you can see this is the first solid for your prismatic cell. Then this is the channel casing. This is the fluid channel. And this is again channel casing, and this is your fluid channel. So I will change this to okay. So this is fluid. So this is also your fluid. Sorry, this is your fluid. And then this is your casing. So I can rename this as a fluid channel. I'll put this as a fluid CHANL. So one more fluid channel is there. So I will make this as also as a fluid channel. So ensure that both are fluid. So here it is fluid. Yeah. So this is the second one. This one here. It should be a fluid here. Then this is your solid, keeping as it is. So I may say this is a prismatic cell. This one is your channel casing. I will put as channel casing. Similarly, you have to put this as a channel casing. So here let's mention this as a channel casing. So let's understand, this is a prismatic cell, this is channel casing, and then fluid channel, this is channel casing, and this is your fluid channel. So in this way we have tried to prepare the prismatic cell, and whatever the heat is generated by this cell will be taken up away by this kind of channel which has been generated over here. So let's proceed with the next part that is related to your mesh. So you may save the work. Let us say, okay, let's save the work. This PC. Thermal management system for prismatic cell with liquid cooling. Thermal management system for prismatic cell with liquid cooling. Okay, let's save the work so that you can access it later on. Okay, now the first part is been done. Now it's okay, one more time just check it. What the prismatic cell should be solid. This is the channel casing, it should be solid again, a fluid channel will be a fluid one, channel casing again should be solid, and last one fluid channel again it will be. So this is the thing which you have to ensure. Then let's open the mesh. This might become a long because we have done right from the preparing sketch, then preparing the geometry of the channels, and accordingly we are going to proceed. So first of all, when the object will be visible, let's generate the default mesh. As for the understanding of your computer, the computer will generate the mesh. Will make it somewhat fine so that uh, the things will be proper for us during the simulation. So we'll definitely change the default mesh size. The default mesh size will be just for your understanding how it comes out, and accordingly the changes can be made on the default mesh size. So based upon the we say the nodes and element, computer may generate the default meshing over here. So it's is been generated. Now it's not that proper as far as the central part has been concerned, so I will put it 0.001. Let's see the statistics. 6 lakh 60, yeah, so that is again quite higher. So I will make it around 0.005 first and just check it. Generate mesh. The mesh is quite finer on the, we can say, sides, but at the central part is not that good. So we'll definitely want to modify the mesh. There is another way of doing it, either by say mesh sizing is one of the operation that can be done, but again it may take some time. So we'll just check it out how it comes out at 0.005. So it is not that proper at 0.005. I will put it around, this is 0.001. Let's make it generate. So I have taken a very fine value. It might take some time. 0.001. So if it is proper at the central part, which we are able to see, then we can continue with this one. But again, we say the finer you, the mesh you will prepare, it will definitely take longer time as compared to. Okay, so it's not that very good, but still I will go with this. You can make it further fine also, but I will go away with this. So let's go with this mesh. We can have a 0. Okay, let's 7,10,600. Okay, so make it 0.005. Let's check it how it goes. I'm not going for 0.001 because it will be too much for the computer to handle. So that is also okay with whatever we had done earlier, like 0.001. Uh, as far as the generating results are been concerned, you can proceed with that also. But definitely it will take more time in this case, and at the same time it will take more time for your simulation also, the CFD post processor. So let's wait. Yeah, so let's wait. So it is taking time for 0.0005. It will be quite finer than earlier case. We'll wait till the time it is completed. Yeah, this looks to be quite fine. Uh, the number of nodes and elements has also increased. So I will go with this. Yeah, even though time required will be more, but still we'll go with this. So let's give the name selection over here. So I'll put here as inlet, this one and this one. I will put here as inlet, and this one I will put here as the outlet. Okay, one more thing which is we haven't done actually. We must have made this channel casing as one part also, but let's say let's proceed, not an issue now. We already selected, so not worried about this now. Okay, so inlet we are done, outlet we are done. I will just hide all other bodies, so select this as a face and this as a face, and create name selection on this. Show all bodies, then channel casing is there, channel casing is there. We can give the name to this also as a channel casing if you want. We can give the name to this channel casing. Yeah, now we'll give this name. Yes, create name selection. Okay, this is inlet. Okay, what happened? Create name selection. I will put it as channel casing. Let us suppose if you are specifying the different material, that time it will be very helpful. Otherwise, even if you don't do, not an issue with that. So inlet, outlet, inlet we have specified, outlet we have specified, cell boundary and all the things we have specified now. So show all bodies. So this is inlet, outlet, then cell boundary, and this is your channel casing. So let's make it update so that the mesh translation to the Fluent will be successful. So once you receive the message, the mesh translation to Fluent is successful, you can close the window. So the message is received, so you can close this window of meshing, and you can now proceed with the setup. Okay, so let's go back to workbench window. Click on the setup, edit. Depending on how many processes you have, I put it around 12. Now we'll do the boundary conditions which is necessary for the given case, and accordingly we'll proceed. So as we have took the finer size, it will take some time to load all these things. So you can just check out the arrows if they are in the proper direction or not. So this is a very important task. So select the transient model time, then we say minus 9.81 over here as a gravity. Then go to the model here. I will put energy equation on, make it here okay. Instead of viscous, I will put it K epsilon, enhance wall treatment, thermal effect, curvature correction, make it okay. Then go to the, as we are dealing with the thermal analysis only, so that's why I'm not done with anything with the we say battery model. So if you are doing this chemistry and other things also consider with the battery, then you can consider that. So fluid, here I will select there's a liquid as a working fluid. So I for sample simulation I put water liquid, close. So I added water liquid. Another thing which I am going to add is the material especially for your cells. So normally it is covered with the nickel, so make it nickel close over here. So you have solid nickel available here. So let's go with the reference values. Sorry, next is the boundary conditions. So put the boundary conditions at inlet. So I will put the velocity here and let us say 0.5 meter per second. Make it apply and close. Then channel casing, then cell boundary we have specified. So you need to specify the boundary conditions here, or that what we are applying is the temperature. If you are applying the heat flux, that is also okay. It depends as what you are doing. So as I said earlier, instead of temperature you may apply heat flux. Select the nickel, make it apply. Now if you are not selecting anything, by default it will be aluminum. So whatever the channel casing which you have considered, it will by default will be as aluminum. So you don't need to actually change it. So thermal, I'll put it 3 nickel, nickel here. uh, Make it say here. If you don't put anything, that will be okay, so I will keep it as it is here. So now next thing is we need to go with the reference values. Tell the computer from where to start. I say it is inlet. uh, Here the fluid channel, go to the initialization, click on initialize. The patch option will be available once you click on initialize. So till that time you have to wait. Okay, now then, so put calculation activities. Let us say auto save after 20. Solution animation, what do you want to visualize? So accordingly put the contours. I want to visualize the temperature, that is total temperature. So put it here, select all. If you don't want the exponential scale, you can click on float, so that the scale will be appear, will not be exponential. Then close this, select the contour and make it okay. So this is what how the scale is appear. So if you have selected exponential, this will come as exponential. Then go to the number of time steps, put it, sorry, I will put it adaptive. Number of time steps is 100. Let's take it 0.5 and let's start with the calculation. So once the calculation is started, you will see the variation in the color contours in terms of your the residual you will see first, and then you will see the contours of total temperature. So it will takes a while for appearing in the animation window. This is just for your understanding. Animation window is been set just for understanding, in order to know whether we are going in the right way or not. So that is one thing which can be understood with the help of the animation window. As I said earlier, it can take some time because we have took a kind of finer mesh. So yeah, so calculation might take some time. So you, once the calculations are completed, you will see one message which is appear as calculation complete. So till that time we have to wait for the results. So we'll wait for another 100 time steps. Once this 100 time steps are been completed, we'll just check out how the post processor shows us the result. Now the contours of total temperature will be visible. It definitely will take more time here. You can see the usage is almost 80%. So time required will be comparatively more. If you find, you may put it some smaller time steps also in order to just check the result, because it is likely that it is going to take more time here. You will see the contours of total temperature, which is also visible. So definitely we'll wait for some remaining 99 time steps. Once that is completed, we'll just check out the results in the post processor. So the calculation is complete. I will just click on, okay, just you can see the contours of total temperature window. I will just click on the workbench window and save the work. Now I'll close the Fluent window so that we can proceed with the next part, that is the post processor. It will take some time. Okay, now let's close the window of the Fluent, make it okay, and open the last part, that is your result. So we'll see the different things. We'll see the first the temperature streamline as well as the contours of temperature, so that we are going to visualize, and then we'll see how the things are proceeding. So let's go with the contour volume rendering. Instead of pressure, I will take it temperature. You can additionally generate temperature values also. So let's say user specified is 293 to around 323 Kelvin. Here resolution I will increase to some higher extent in order to visualize it in quite better way. So this is how, let's make it okay. So let's make it apply. It will take some time to load. So higher the resolution, the time required will be more. So now we'll see the contours of temperature first. I think the utilization increase. Yeah, the RAM utilization has increased. So it will take some time. Just check out this one. So it is almost around 100%. It will take some time. Yeah, it's already there. Now it's time to visualize the streamline. So you select start from inlet. I will say instead of velocity, I will put it as a temperature streamline. number of particles, you can see, uh, I will put it to higher value. Let's make it apply. So now it will be a temperature streamline that is going to be visible. Let's properly arrange the legend over here. So appearance, I will change it to fixed, and then number of value tricks, I will put it to 11. This I will put it to some lower value, and this will be to higher one. Okay, so this has been done. uh, there are two things. One, it is volume rendering, and this is your temperature which streamline. So let's see the first streamline here. Sweep animation, click on this one and just visualize how the particles are moving. The particles are moving from this inlet to outlet. So this is one of the visualization that we can have for the particle. Let's stop it. So this will stop till the time last particle is coming out, till the time the simulation will go on to show you the things. So we'll just wait for some time. Let Okay, so this is there. Now go back to and select the this one also, so you can visualize how the things are here. If you want more number of particles, you can change this streamline to more than 150. So that is also one way of doing it. Let's visualize this one more time by with some different symbol size over here, say around 0.6, and just visualize. So you can see how the particles are coming here and they are moving towards the other end. So this is how the one of the visualization that can be done for the fluid particles which are taking heat from the cell. So let's stop this. So in this way you can really understand how the temperature distribution, as well as how the fluid, the liquid cooling which we are doing, how it behaves when during your simulation. So just wait for the last particle to come out. Try to wait for the system, because the system may get hang, and that's why till the time the last particle is not coming out, you have to wait. Otherwise the system may not respond if you try to force close any of the app. So that one thing you always need to ensure when we are doing this, especially we are running the streamline variable here. So till the time last particle doesn't cross, it will not stop the simulation. So yeah, this is, I think it will not stop now. This is the last one. So this has stopped now. So you can visualize it in some different way also. So likewise things can be done. Either you want whatever the things you want, accordingly it can be visualized. Thank you.